Hi, and welcome to ParkTechTalks. I'm Gabriela, and today I'm going to give you a tour of our Marshall & Williams Plastics Extrusion and Orientation Lab, also known as our Biax pilot line. This lab provides a convenient and confidential environment for extruding and stretching polymer materials, and it is a place of experimentation where you can test drive machinery, conduct product and process development trials, and produce samples for test marketing. Today, I'm going to show you each section of our Biax lab and show you how each machine works together with the next one to biaxially orient a polymer material. First up in the Biax line is our extrusion system and casting machine, which can be operated independently from the downstream process to produce unoriented cast film and sheet products, or used in combination with downstream stretching equipment to produce uniaxially and biaxially oriented films. With this equipment, you can use a single extruder or many combinations of up to 4 extruders in order to co-extrude a variety of multi-layer structures. In this system, we use general purpose barrier screws, and we have our own key filters brand screen changers as melt filtration systems. Directly after casting, the web passes through an upstream thickness gauge, in which we use an X-ray gauging system from Scantech to measure the thickness of the material before this orientation process. Following the upstream thickness measurement, the material enters the Machine Direction Orienter, or MDO, a space-saving vertically configured machine containing 6 18-inch diameter, 30-inch wide rollers. The MDO features a 2-stage draw section with adjustable gaps to accommodate a broad variety of stretching conditions. In this MDO, the temperature of each roller is independently set and precisely controlled, using a hot oil system and a max oil temperature of 550 degrees Fahrenheit. After the polymer web is oriented in the machine direction, it is stretched in the transverse or cross web direction in order to be fully biaxially oriented. This occurs through our transverse direction orienter, or TDO machine. This machine produces oriented film and sheet products by heating the polymer web in a gas-fired hot air oven and then stretching it in the transverse or cross direction between a series of clips. These clips grab the edges of the web, and then they travel down a pair of adjustable rails that can be positioned to diverge from each other, thus stretching and further reducing the web's thickness as it travels further downstream. There are 3 independently controlled heated oven zones in the TDO: a preheat zone of 13 feet, a stretch zone of 9.5 feet, and an anneal zone of 10.8 feet. There's a max temperature capability of up to 650 degrees Fahrenheit, and there are variable speed fans in each zone to control the air velocity within the machines. Our minimum TDO inlet width is 8.5 inches, and our maximum outlet width is 85 inches, thus accommodating for a stretch ratio of up to 10 times the width of the initial material. After exiting the TDO, the web is now a fraction of its as-cast thickness while achieving enhanced performance properties through biaxial orientation. The web's final thickness is checked as it passes through a second Scantech X-ray gauge. Then it proceeds to the continuous turret winder as the final part of the process. This turret winder uses a load cell trimmed AC vector drive and has a maximum material width of 80 inches with core sizes of 3 inches and 6 inches. The winder has a maximum package diameter of 30 inches. Just like the MDO and TDO before it, the turret winder is controlled using a Rockwell automated PLC system that integrates all machines and functionality throughout the entire pilot line. So after this process of biaxial orientation, there's a newly wound roll of the biaxially oriented polymer material ready for production use further downstream. Thank you for watching today's tour through our Biax lab here at Parkinson Technologies in Woonsocket, Rhode Island. You can visit our website, ParkinsonTechnologies.com, to look at further blogs and videos.